Hi, in this video we will learn how to identify corners. Corners can be really helpful to define an object on an image. Most importantly, the characteristics of a corner allow us to detect them rather easily. Imagine that we have a movie window that we will move over an image. In a patch of constant color, if we move the window up and down or left or right, the resulting image will be always similar. If we reach an edge, then we will see a change. But this will happen only in one direction. We can move the window in the same direction of the edge and the window won't look different until we find a corner. If we move the window over the corner, the image that we see will change on every direction. Therefore, to identify the corners, we could move our window around edges until we find one. However, there is a better way to identify corners. The Harris corner detector uses a matrix representation H, like this one, in which we include the image gradients for x and y. Then the detection is given by the formula R is equal to the determinant of H minus the trace of H squared multiplied by a constant. This formula tests whether the product of the eigenvalues is larger than the average. Then, if R is close to 0, it means that the window is in a constant patch. If R is negative, we are in an edge, and if R is positive, then we find a corner. The Harris corner detector is really popular. However, there are different circumstances in which it might not work. For example, this filter can work in any orientation, but not at different scales. If we design the filter to find a corner in a specific neighborhood, it will fail in a larger or smaller scale. We would like to have a method to find specific features that can be used later to identify objects. And here is when we should talk about interest points or blobs. These interest points are a subset of pixels that contain enough information that can be used later to identify the same feature at a different scale of orientation. For example, in this image, many patches can be a blob, but not all of them can be useful. If we select an edge, we might find that many other patches have a similar structure. That is the main reason why we focus on corners. However, we can get a little bit more abstract and say that any patch that has a differentiable structure can be a point of interest. Let's take a look at these two images. As you can see, they are in different lighting conditions, orientation, and a different scale. However, if we take this patch and we rotate it and scale it, we will find a good match. So in order to achieve this, we need to know the orientation, the scale of a point of interest to be able to match it with a similar patch. But we will see how to do this in the next video. Okay, in this video we review the Harris corner detection and we talk about the point of interest. So see you in the next video.